Welcome to EDU World Space.
From reading the problem, we know that the battery is 15 volts. The resistance of the appliance is 75 ohms, and there is an ideal voltmeter that's connected across the appliance, which reads 11.9 volts. And in part A, we're asked to find how much power is being dissipated by the appliance. So actually, we can readily find this if we use the equation. Power is equal to V squared over R. And this V squared is what the voltmeter reads. So that is 11.9 volts squared over 75 ohms, which gives us a dissipated power of 1.89 watts. And now in part B, we're asked what is the internal resistance of the battery. So in order to find the internal resistance of the battery, we just take the sum of the potential difference in a closed loop, right? So if we start at some point and we end there, then we know that the total potential difference is equal to zero. So we have a battery, and then we have a voltage drop associated with the internal resistance of the battery, and then another voltage drop that's associated with the appliance, and these are all the voltage drops there, or the potential differences that are in the circuit. So from here we can find that E minus IR over I is equal to the internal resistance, but notice that we actually don't know what the current is. But that's not a problem because we can find the current quite easily using P is equal to IV. And this V is what's measured by your ideal voltmeter. And we already calculated the power in the first part. So here we can find current is equal to power over the voltage, which is 1.89 watts divided by 11.9. And that gives us 0.16 amperes. Okay, so now we're ready to find the internal resistance because we have everything that we need. So let's do that on the next page. Okay, so remember we have the internal resistance is the EMF of the battery minus the drop in potential due to that resistor divided by the current. And that's 15 volts minus 0.16 amperes times 75 ohms divided by 0.16 amperes. And that gives us an internal resistance of 18.75 ohms.